Right, let's do an example of the second law of problems. Example 1. What is the acceleration of each box? I'm going to make this slide smaller so that I can talk about it and write next to it. Okay? This is a Newton's second law problem. And let me tell you how you would know that, other than it being written on a page or in a PowerPoint about Newton's second law. If a problem asks you about acceleration and gives you forces, so notice here, this is a Newton, so it's a force, Newton's force, Newton's force. If a problem has acceleration and forces in it, it's going to be a Newton's second law problem. And that's a key test-taking strategy. If you see accelerations and forces together, your mind needs to go Newton's second law, F net equals mass times acceleration. And just to get you used to it, even though all of the problems I'm doing tonight can be worked out in just x or just y, I'm going to do all of them in x and y, just so it doesn't come as a shock to you, like it did in kinematics when we start doing x and y. So I'll make x as blue tonight. F net x equals mass times acceleration in x. F net y equals mass times acceleration in y. And the acceleration in y does not have to be g in Newton's second law problems. G will be important and we will use it, but the acceleration in y is not automatically g like it was in projectile motion problems. Acceleration in y being g only applies, always being g, only applies to projectile motion. And this is Newton's second law. Okay, so let's work with that first box, the one that's 20 kilograms. We'll do x and then y. F net x equals mass times acceleration in x. To find F net x, we need all of the forces in x. So F net x, we need all the forces. And we're going to give them direction using that coordinate system I declared earlier. Positive x is to the right, and positive y is up. And so Ashley asked the question a few days ago, why aren't we dealing with positives and negatives when we have up and down, left and right forces? For Newton's second law, we will have to deal with positives and negatives. So I see one left and right force, and that's the 30 newtons to the left. And since that's to the left, that's negative x, so F net x is 30 newtons to the left, which makes it negative 30 newtons. I don't see any other left or right forces on that first box, so that's F net x. And we know that F net x equals mass times acceleration in x. We're trying to find the acceleration, so let's solve for it. F net x equals mass times acceleration in x. If we want acceleration, we divide by mass to get acceleration by itself. So F net x over mass equals the acceleration in x. And now I just plug in the numbers for F net x, which was negative 30 newtons, and my mass, which was 20 kilograms. So this is negative 30 newtons over 20 kilograms, which gives me negative 1.5 meters per second squared. And that's the acceleration in x, equals ax. Okay, I'm going to box off a little area to do y in, because I don't want these to run together even though I'm color coding them. So I'm going to do y over in this little area. Alright, we already have F net y written. F net y equals mass times acceleration in y. We need all of the forces in y, including their direction. Well, there is a force of gravity, and that points down, so negative Fg. And there's a normal force, which points up, so positive normal force. You should now be able to tell by looking at that box that the force of gravity on it is 200 newtons. 20 kilograms times 10 newtons per kilogram is 200 newtons. At this point, you need to be able to just whip out weights when given masses. So F net equals negative 20 newtons, because gravity is pointing down. And if that box is at rest, the up and down forces are balanced, so your normal force has the same magnitude as your force of gravity, and so our normal force is also 20 newtons. Meaning that the total force in y is 0. So F net y is 0. Now we want the acceleration in y, so let's solve this equation for acceleration. F net equals mass times acceleration, divided by mass. F net over mass equals a. Okay, F net is 0. Mass is 20 kilograms. 0 divided by anything is 0, so acceleration is 0 meters per second squared. And that is my acceleration in y. So I only have an acceleration in x, and it's negative 1.5 meters per second squared. So we found the acceleration of that first box. All right, let's find the acceleration of the second box, and hopefully this will go faster. I'm going to jump into x. So F net x equals mass times acceleration in x. We need to know the net force in x, so let's write that out. F net x. I see a 30 Newton force to the left, and remember from earlier, up is positive y, right is positive x. So that 30 newtons to the left would be negative 30 newtons. I also see 70 newtons to the right, that would be positive 70 newtons. I don't see any other forces in x, so F net x is negative 30 newtons plus 70 newtons gives me 40 newtons. Okay, and now I want the acceleration of that box. Solve for acceleration from this equation. F net equals ma, and we're doing this in x. Divide by mass. F net x over mass equals acceleration in x. My F net was 40 newtons. My mass was 40 kilograms. I made this problem too easy. 40 newtons divided by 40 kilograms gives me 1 meter per second squared. That is my acceleration in x. Check and burn. Now let's do y. F net y equals mass times acceleration in y. My y forces will be gravity, which is pointing down, so negative Fg. Normal force, which is pointing up, so positive. The force of gravity on that box, its mass is 40 kilograms. Force of gravity, or weight, is mass times gravity. Gravity is 10 newtons per kilogram, so 40 kilograms times 10 newtons per kilogram